Courses in the cement industry. Present to you. In this course we will explain, take-up device. The system incorporates mechanical, or automatic tensioning devices or take-up, to make sure that the belt remains tight against the drive pulleys, to reduce slippage and improve energy efficiency. The automatic tensioning device is often referred to as a gravity take-up or a counterweight. Take-up device are installed in the conveyor return side, to ensure suitable tension of the belt against the drive pulleys and the automatic take-up. At first you will review together parts of conveyor belt, with all its components. 1. Tail pulley. 2. Snub pulleys. 3. Belt scraper. 4. Impact idlers. 5. Return idlers. 6. Belt. 7. Bend pulleys. 8. Take-up pulley. 9. Take-up device. 10. Carrying idlers. 11. Pulley cleaner. 12. Belt cleaner. 13. Head pulley. Together we watch this video, that shows us the components of the conveyor belt. Belt elongation. The elastic belt elongation is determined by the modulus of elasticity acting in longitudinal direction, all supporting belt plies, tensile member, and by the curve of the local belt tensions, in the top run and in the return run. The permanent belt elongation depends on the material, and the constructive design of the tensile member, and is affected by the amount, and the time of exposure to the belt tensions. Belt tensions. The belt tension of a conveyor belt system is of a varying value along the system flight, and is governed by the following influencing factors. 1. Length and local track of the system. 2. Number and arrangement of the pulleys as driven and braked. 3. Characteristics of the driving and braking equipments. 4. Type and location of the belt take-up device. 5. Operating and loading state of the system. In addition, there are required minimum belt tensions which 1. Ensure the friction grip on the pulleys, as driven and braked. 2. Limit the belt sag between the idlers, with a view to the belt being tracked correctly and satisfactorily. Introduction about take-up device. Some form of take-up is required on all belt conveyors, for the following reasons. 1. Ensures proper amount of slack side tension at the drive pulley to prevent belt slippage. 2. Ensures proper belt tension at loading and other points along the belt conveyor, prevents loss of troughing contour of the belt between idlers and avoids spillage of material from the belt. 3. Compensates for changes in belt length. 4. Allows belt storage for making replacement splices. Without storage, small sections of new belt would have to be added, requiring 2 splices for each splice repair. Take-up device movement. Take-up should 1. Provide sufficient movement to accommodate acceleration or deceleration surges without having the take-up strike against its stops. 2. Allow for some live storage of belting so that, in the case of an accident, it may not be necessary to splice in a short length of belt. 3. Allow for changes in belt length, due to stretch or shrinkage. Take-up pulley. Pulley attached to the counterweight, to transfer tension to the belt. Take-up unit. 1. Device to maintain pre-tension on belt, thus avoiding belt slip at drive pulley, and belt sag between idlers. 2. This type is more suitable than the other for discontinuous material feuding. 3. Other type is manual take-up. The take-up pulley is mounted on screws, or sometimes hydraulic or pneumatic cylinders, to provide tension manually. Automatic take-up. 1. More desirable in maintaining consistent tension. 2. Can be installed horizontally, vertically, or on an incline. 2. Can be gravity or power operated by hydraulic, electric, or pneumatic means. Most common type is gravity. Gravity take-up. 1. Gravity take-ups are often built up with spilled material. This causes excess tension and uneven operation. 2. Take-up frames are often loose to prevent binding, but this leads to belt mistaking. 3. Take-up frames can be rebuilt to remove the slop, and dog houses can be installed over the take-up pulleys, to prevent spilled material getting into the pulley slides. Manual take-up. 1. Is compact and low cost, but because the take-up is at best periodic, the belt tensions are almost always too high or too low. 2. A manual take-up is not recommended unless an automatic take-up is not feasible, because of space limitations, or if take-up considerations are not as critical. Types of manual take-up include 1. Screw. 2. Ratchet. 3. Jack operated. Take-up device. Generally the take-up device of a belt conveyor system shall be designed so, with regard to the achievable take-up distance, that it will absorb the lengthening of the belt arising from its 1. Elastic elongation. 2. Permanent elongation. The main equation, equals. Where take-up length, in meter. Distance center to center, in meter. Elongation, in percent. Take-up travel and initial position. Recommended minimum take-up travel in percent, of center distance. See this table. Recommended initial take-up position. See this table. Take-up range for screw-operated, take-up systems. The following factors must be taken into account, when determining the tension take-up range. The approximate amount of elongation, of the belt resulting from belt load for determination of the production length tolerances of the belt. Possible external influences, temperature, stop-and-go operation, which may necessitate a higher elongation, tension, than normal or justify the allowance, of a tension take-up reserve. Generally, depending on the load, an elongation at fitting in the range, of approximately 0.1 to 1% is adequate. A tension take-up range, x, of 1%, of the belt length is therefore sufficient. We follow together, take-up range for screw-operated, take-up systems. Tension take-up range. See this example. To calculate the tension take-up range. Take-up range for load-dependent take-up systems. 1. With gravity-operated take-up systems, the tensioning weight must generate the force, F2, in order to achieve satisfactory grip, by the belt on the drive drum. Spring-loaded, pneumatic and hydraulic take-up devices, operate in similar fashion. 2. The tensioning weight must be capable of moving freely. The take-up unit can only be installed after the drive unit. Such a design cannot be used with a reversible conveyor. 3. The take-up range is a function of the effective pull, the required force, F2, the belt length, its delivery tolerance, the tension reserve, Z, and the belt type. We follow together, take-up range for load-dependent take-up systems. Determination of Fr. The main equation, equals. Example for determining the tensioning weight Fr Newton, with a 1808-degree arc of contact. We follow together, take-up range for load-dependent take-up systems. Determination of Fr. Another case. The main equation, equals. Example for determining the tensioning weight Fr Newton, with an angle, as shown. Ftr equals weight of tension roller Newton. We watch together, a group different types for take-up device. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.